So we looked for points where our quadratic and linear would cross. So sometimes maybe we had them crossing in two spots and we had two solutions. Write this down. Okay, or maybe we had a situation where they only crossed in one spot. Last but not least, we had some where they would never ever touch. So we had no solutions. Today we are going to do that same thing, but instead of finding the solutions graphically, we are going to solve them algebraically. So our solutions are the set of all the points that make both the equations in our system true. They always have to make both the equations true to be a solution. Good. Okay. So let's test. We're going to test some solutions. So here we have a fun little system. It's got a linear function and a quadratic function in it. Okay, here I've got a point that has an x and a y coordinate, and I want to know if this is a solution to that system. So I plug it in to equation 1. Does 3 plus 4 give me 7?
Yes.
Yeah. Check. All right, here's equation 2. Does 4 equal 3 squared plus 1?
No.
No, because 3 squared is 9, plus 1 is 10, and 4 does not equal 10. So 3, 4 is not a solution. Okay, let's try 2, 5. So here's my x, here's my y. Plug them in. Does 2 plus 5 give me 7? Yep. All right, here's equation 2. Is 5 equal to 2 squared plus 1?
Yes.
Yeah, because 2 squared is 4, plus 1 is 5. So 2, 5 is a solution. Okay, now we're going to go back in a time machine. It was kind of a traumatic time. Some of you may have blocked it out, but we're going back to Unit 6.
No. Oh no.
You'll be fine. You'll be fine.
So mean.
Wah, wah. Okay, we're going back to Unit 6. Do you remember any of our solution methods
Nope.
for solving quadratics?
Complete the square.
Completing the square. Good.
Factoring.
Factoring.
The ZPP.
Yes, the ZPP. What else?
GCF.
Yes.
Formula.
If we have a GCF, we can just factor that out. Yes, the quadratic formula. One more I can think of. If we have no BX term.
Standard form. Square root.
Square root method. Okay, so that was a little brainstorm of our possible solution paths. Now, because solving systems requires that we find one variable and then plug it in and find the other answer, the other part of our solution, Do you think I'm going to give you answers that have some crazy radicals in them and then have you plug it in?
No.
Probably not. So, to calibrate your expectations, even though we're going to be using our Unit 6 tricks, we are going to be solving easier Unit 6 problems because it would be too much to do all of it at once. Any questions about that? Okay, so we're going to have much friendlier answers. Okay, we're thinking of integer answers. So not radicals. Probably not even fractions if we've got quadratics in our systems. Any questions about expectations for what we get? Okay, here we go. We are going to start first using substitution. We'll try elimination on the back if we feel up to it. Otherwise, we can just keep doing substitution. So, do you see that I have two equations that are both solved for y? Okay, this is going to be a long video if I don't get any acknowledgement that I've said words. Do you see that both of my equations are solved for y?
Yes.
Okay, so this one's ready to go for substitution. I have here an expression that is equal to y that I can substitute in for that y right there. Easy peasy lemon squeezy. So I get x squared plus 1 equals x plus 1. Doesn't this look a lot like what we did in Unit 6? Yeah, we had variables on both sides, no problem. So the first thing we did was we replaced y with an equivalent expression. Next, we are going to solve for x. What do you notice about the ones on both sides? They're both positive, so if I subtract away 1 from both sides, they cancel out. Bye. Okay. The vast majority of these tricks required that we have standard form set equal to 0. You guys remember that? Ax squared plus bx plus c equals 0. Standard form set equal to 0. Everybody with me? So I want everything on one side. So I'm going to subtract away that x from both sides. Minus x minus x. Now I've got x squared minus x equals 0. Is anyone mad that I didn't combine the x squared and the x? Do you remember that they are unlike terms, so they're not combinable? Correct. One is squared and one is linear. All right. Look at our list of methods. Do you see anything that is jumping out at you right now? Tell me about x. X is jumping out. Why? Do my two terms have anything in common? X, because x is the has a variable. They both have an x in common. Yeah, x is the greatest common factor, right? It's the GCF. So here I have a GCF. So I'm going to factor out the x that they have in common. So let's think about what would be left behind in parentheses if I factor out an x. X squared, factor an x out, what's left? Another x. Bring down the negative. X is here, I took it out, what's left? 1. A negative x over an x gives us a negative 1, right? Okay. Cool. Now I have two beautiful factors set equal to 0. What am I ready for? Yes, the ZPP. ZPP. So I know that x must equal 0, and I know that x minus 1 has to be 0. So my first x is just 0, right? Duh. What about this one? 1. Okay, in Unit 6, this is where we would put them in curly brackets, tie a bow on it, we're done. But in Unit 8, not only do we have to find the x's, we also have to find their y values. Okay? So we are going to substitute both of our x's and find their y's. Because remember, we are looking for points. Points have x's and y's. Now, would you rather take an x and square it and add 1, or just add 1? Just add 1. So you should get the same thing regardless of which equation you use. So choose your own adventure and make it an easy one. Okay, don't work too hard. So the y should be whatever my x is, 0, plus 1. What's y? 1. Okay, this y should be 1 plus 1, which is 2. You guys thought that was going to be worse, didn't you? Wasn't so bad. So now we just write our points. Hard part's over. So my first point has an x of 0 and a y of 1. My second point has an x of 1 and a y of 2. All right, check out step 5. These are both solved for y, so it would be really easy to put both of these in y equals, right? That's what we're going to do. We're going to check our calculator to see if we got the right answer. So it was x squared
X² + 1.
plus 1 and x plus 1. Okay. Okie dokie. So first I can look at a graph, and sure enough, boom, boom, crosses twice. Now I can check my table. When my x was 0, both of my y's are 1. So my solution is 0, 1.
And then at 1 is 1, then flip it 2.
Yeah, when my x is 1, both of my y's are 2. Okay, so you don't have to wonder, did I get it right? You can put it in and check your table. Now, if I was thinking very strategically about this, could I put these in my calculator before I start doing any work, and then check along the way to make sure that I was getting my x's and y's right? Yes. Okay, you get a calculator for the test. So here's the thing. The answer is like 1 point. Okay, the rest of your work is the rest of the 4 or 5 points. Okay, so you have to show work. It's not enough to show the answer. If you just show the answer that you got from the calculator, that's an F, because you didn't show me that you know how to do the problem. So use the calculator to check your work, but make sure that you show the steps. Got it? Okay, perfect. All right, next page. Guys, we have the same thing here. We have two equations. They're both equal to y. Okay, so we're going to replace y with an equivalent expression. This whole thing is equal to y, so I'm going to plug it in right there, substitute it in. Okay, that gives me x squared plus 2x minus 3 equals x minus 1. Take away for the x from both sides. We're going to solve for x. Minus x minus x. What else can we do to both sides? Careful. Add 1. Add 1. Good. Okay, that gives us x squared plus x minus 2 equals 0. We have standard form set equal to 0. We're ready to rock and roll. Okay, dig in your Unit 6 bag of tricks. Do we have a GCF? No.
No.
Okay. Do we have an even b where we can complete the square? Nope. You want to try for magic numbers? Try some factoring? All right, let's do it. So remember that we want to multiply to the c value and add up to the b value. So we're looking for factors of -2, the c, that add up to 1, the b. That kind of looks like I made the x the b. The 1 in front of the x is the b, if that was not clear. Okay, it is 2 and -1. You are correct. Everybody okay with how we got that? Okay. So my binomials that multiply to my trinomial are x minus 1 times x plus 2. What am I ready for? Yes, I have factors set equal to 0. I am ready for my ZPP. The zero product property. It says that if my product is 0, then one of my factors has to be 0. So I know that x minus 1 has to be 0 or x plus 2 has to be 0. What are my x's? 1 and good, -2. Now look at the equations. Which one would be easier to substitute back into to find the y's? Yeah, the linear one, the second one. So let's do that one. We found both x's. We are going to plug both of them in to find both y's. Okay, we're just going to subtract 1. So y equals 1 minus 1. So y is 0. Okay, this one, y equals -2 minus 1. -3. Okay, I'm going to write my solutions and check them on the calculator. So that would be 1, 0, and -2, -3. All right, let's plug them in. Put them in the calculator. So x squared, was it plus 2x minus 3?
Yes.
Thank you. And what is it, minus 1?
Yes.
Okay, check out my graph. I do, in fact, get 2 solutions, so that's good news. Check my table. Okay, when my x is -2, both functions give me -3. When my x is 1, both functions give me 0, so we did it correctly. Questions? All right, let's try another one. So far we've used GCF and we've factored, finding magic numbers so we can get binomials. Let's see what the, okay, do you guys want to keep doing substitution or do you want to try elimination?
Elimination.
Want to try elimination?
I think we should try something. Get out of our comfort.
Okay, we're going to do elimination. And if we don't like it, then we can go back to substitution for the last one. I would feel bad, though, if we didn't try it. Okay, so the whole point with elimination is that we can strategically multiply, if necessary, to cancel a variable when we add our equations together. So the variable that you're going to have to cancel if you're doing elimination on quadratic linear is the y's. You have to go for the y's. Do you see that if I were to try to cancel my 2x's, I would still have x squared and y's left? You see what I'm saying? Okay, so you can't mess with the x's. You have to go for the y's. So, notice that my y's both have already a coefficient of 1. I need one of them to be opposite. Yeah, I need one of them to be -1. Okay? Looking at my equations, I already have a positive a value of 1 for my quadratic. I want to keep that. I want my a value to be positive. So I'm going to multiply my top equation by -1. And then it will be -y equals positive 2x minus 3. My second equation I'm going to leave alone. It's still y equals x squared minus 2x minus 1. Okay, we add them together. Okay, my y's cancel and I get 0. Can I combine the 2x and the x squared? You are correct, why not?
Because one of them has exponent, the other one doesn't.
Yeah, they don't have matching exponents. Yeah, I can combine the 2x and the -2x, but the x squared doesn't combine with anybody because we don't have any like terms for him. So the 2x and -2x cancel. We have a -3 and a -1, which add up to -4. Okay, do we have a GCF? We don't. We don't have an x or a 4 or 2 in common. Do we have a trinomial where we would find magic numbers? Okay, do we have a bx term? I see an a of 1 and a c of -4. Do you see that we're missing the bx? So if we have no bx term, which method can we use?
Square root.
Square root, right? So we're going to do square root method. We have no bx, so we're going to use square root method. All right, so I need to get the squared part alone so that I can take the square root. So I'm going to add 4 to both sides, and I get 4 equals x squared. How are we going to undo squaring? Square root. I have to take the square root of both sides. Don't forget, we get 2 solutions, a positive one and a negative one. Okay, what are they?
-2.
Correct, -2 and +2. Okay, which one do you want to use, my line or my parabola to find the y's? Okay, That's probably what I would have picked also. So it says that the y is -2 times whatever x is plus 3. So we're going to plug in a -2 for the x. -2 times -2 is 4. 4 plus 3 is, yeah. Okay. Y equals -2 times whatever x is plus 3. Plug in the 2. -2 times +2 gives me a -4. -1. So my solutions are -2, 7, and 2, -1. Okay, what do you guys think? Do you want to do another one with elimination or go back to substitution? Substitution?
Is easier.
Okay. I thought so too when I was a kid. All right, here we go. So I have a whole expression that is equal to y. I'm going to take it and plug it back in. Substitute it for that y right there. So that gives me x squared plus x plus 6 equals x plus 2. Just made my monster equation. Okay, Jacob says to cancel both of the x's because I can subtract x away from both sides. Subtract 2 from both sides, and I get x squared plus 4 equals 0. It's kind of looking a little bit like what we had on the left. Do you see that we have no bx term?
Mm-hmm.
Okay, you want to try square root again?
Yeah.
Okay, so subtract away the 4 from both sides, and I get x squared equals -4. Square root, plus and minus. Okay, anything look a little strange to you? Any antenna going up?
You can't have a negative under the radical.
Yeah, we can't have a negative under that radical, not until algebra 2. Okay, whenever we have a negative under the radical, that means that we're going to have imaginary solutions, and we don't mess with them in algebra 1. So, if we have a negative under the radical, then we have no real solutions. Okay, let's check and see what this looks like on the calculator. So we'll plug them both in on our y equals. So it was just x and then a 6. Was it plus 6? And then x plus 2. Thank you. Okay, look at my graph. Now, remember I said that we could use the calculator first. Wouldn't this be valuable information to have so that while you were working this out, you knew that something weird was going to happen and you were going to have no solution, right? Just saying. You can put it in your calculator and then use that to help guide your work to keep you on track. Any questions? All right, work time.